Okay, so in this video, I'm going to show you guys a new way that you can express different ranges of numbers. By ranges of numbers, I'm talking about something like we would use right here. We've talked about inequalities before. This would be like a sandwich, I would call them, with an inequality. We're basically talking about all the numbers between -4 and 10. Those are the numbers that we want in our problem. So x is going to be between -4 and 10. The numbers in between that are going to be our results. If we were to graph this on a number line here, we would have -4, we would have 10. There would be solid circles at both of them, and we would shade in between. And this is a perfectly good way of writing that, but it's not the only way. And as you go on to more advanced math classes, you will see them kind of shift over to a different way of writing things often. So this is called interval notation. And the way I could write this thing, express the exact same thing, is I would put the following symbol. It'd be a square bracket. I would have my -4, comma, my 10 right here. So the square brackets tell me I want all the numbers between here and here in my solution. So this and this mean the same thing. This is just a different, maybe shorter way of writing it. What you'll sometimes see outside of this here, depending on how fancy they're getting with it, you'll see your X and a little, like, it looks like an E almost, a symbol like this, like a curved E. Basically what this is saying is that x has to be an element in this set, so x has to be somewhere between -4 and 10. So sometimes you'll see it with this in front of it, but that's basically what's going on there. So on my second problem here, it's the same sort of idea. If I were to graph this on a number line, this time though, I would want the 17. I would not want the 44 because it's just less than there. So I would have an open circle and I would still shade in between. So when I'm writing my symbol here, I would have my 17 in a square bracket, and since I don't want 44, when I write that part, I'm going to use a parenthesis instead of a bracket. So parenthesis means don't count the endpoints. If you see a bracket, you do count the endpoint in your range. Silly maybe way to remember it, there's a line underneath or equal to right here that you actually count. When you do a bracket, it's like there's a line there for or equal to. This one's rounded and doesn't have that line at the bottom. So this is how you would express that interval. On my next one here, I have just x is greater than or equal to 12. No other part to it. It's not a sandwich like the last one. So if you think about it in a number line, we would be going from 12, it's greater than or equal to, so we want 12, and we would keep going all the way up to the right. So if you think about where we start and where we end, we start at 12 right here, and we end, technically, we're going to keep going into, as we approach infinity. So if it goes on forever in a direction, we put infinity on that end of the interval. And we can't actually equal infinity. That's never going to happen. So you will always have a parenthesis when you use infinity right here. So this would be how you express that interval right there. It starts at 12, goes all the way to infinity. And on these last two here, I forgot my x is an element of, just to be official with it. So on my last one here, on this slide anyway, I have x is less than 1. Less than 1 is going to be open circle at 1, shaded to the left. We want everything here. So my interval actually starts at this end of the graph at -infinity. So I have x an element to the set, -infinity. Again, I use a parenthesis anytime you have infinity involved. And it's going to keep going all the way till it hits 1, but we don't want to use the 1. So we put an open parenthesis right there. Sometimes when you're doing these, you may end up getting two open parentheses with numbers, and it may look a little bit like just an ordered pair or a point. It's the context clues that are going to tell you what's what. Alright, a couple examples to kind of wrap up our video here. We have one last type of inequality we have to discuss, and that's the OR inequality. So I could have two pieces to it like I do in that example there. So what I would say on this problem, x has to be less than or equal to -7. So -7 less than or equal to, so solid shaded this way. And +10 is going to be an open circle shaded this way. So I can't express this as just one interval because there are two pieces to it. There's the piece over here and the piece over here. I'm just going to write them as two separate intervals and lump them together. So the first one would go from -infinity to -7, counting -7. So I put a bracket there. I put a U for union in between my two pieces here. That just means, all this u means is it's going to be this part and the next part I write lumped together. So if there's two parts to your interval, just put a u in between them. The second one starts at 10, but we don't count 10. So parenthesis there, all the way to positive infinity. So this would be my interval written in two pieces with a u for union in between them. So on my next one here, I have two pieces again, but I'm actually going to graph this one to show you guys something. The first one starts at 3, open circle, greater than, so I shade to the right. So all this gets shaded. This one starts at 5, also open circle, but it's already been shaded from this part, so technically it becomes a closed circle because the shading already happened there. And this one's less than, so we shade right here. So actually everything on the number line gets shaded. We would have said the answer is all real numbers to this if that happened before. But writing this as an interval, we want to go all the way from negative infinity to positive infinity. So that's how you would actually write that. You would be negative infinity to positive infinity, like you see right there. And final problem of the video, let's write domain and range for a graph, because often you'll see that done with interval notation. So my domain is going to be my x's. So I'm going to write x is an element of, and the domain of this graph is going to keep going left, it's going to keep going right. Domain is all real numbers, and all real numbers you write just like we did up above there. So x is just going to go from negative infinity to positive infinity, just like that. My range, on the other hand, range is the y's, and that is not going to be all real numbers. The range is from here downwards, so it's at 3 and below. We would have written that as y is less than or equal to 3. So as an interval, that's going to go from negative infinity to positive 3. Recall how we wrote those in previous examples. So that's basically how you use interval notation to accomplish the same thing that inequalities do.